All right, we are live. Welcome to another Game Dev Hangout. I'm here with Jason Storey, um, friend of the channel, been on many streams. And today we're going to be taking an introspective look at our own code. Going to try to rip apart some projects we've been working on, talk about through some of our thought processes. And yeah, it should be fun. You excited?
Yeah, I kind of feel like we owe everybody. We've been spending so long looking at other people's code. People might be curious what our own code looks like.
Yeah. We've done, for those of you who hadn't joined some of our earlier streams this year, we had been doing a lot of code reviews. And, you know, when you're reviewing someone's code, you have to be critical, not judgmental, but you have to get into the weeds a little bit. And we were thankful for all the folks that, were brave enough to send in their code and let us have a look at it. But now we're going to take a look at our own code. And, if you're in the chat, feel free to point out anything you'd like, be as critical as you'd like. But hopefully we can get to the bottom of, some of the decisions we made and have sort of an educational experience out of it. So see a lot of faces in the chat, a lot of recognized faces, a lot of new faces. I see Lewis there. Hey, man, thanks for coming through. We're streaming at kind of a different time than we normally do, so I appreciate those who made it out. In fact, I think I no longer have like a standard time. It's just like whenever the guest is available. And actually, this time it was my fault because, it's been busy working with this pandemic and everything. So this was like the one pocket of time I had. So thank you, Jason, for making the time.
Yeah, no problem. It's been a while. I kind of feel like we've been meaning to do this for a while. So
yeah, definitely. I'm looking at the stream now. I think I should have flipped you so we're facing each other, but people just have to get over it. Juliano says, "Say hello to Brazil." Hi, Brazil. Good to see you. Hope everything's doing good. So also, I should say that as we're going through this, and if you have any questions about the code or maybe not about the code, feel free to drop that in the chat. Lewis says programming standard time. That's pretty funny. I like that. PST. Oh, it's taken, but we'll think of a better one. That's funny. So yeah, drop your questions in the chat, and yeah, we'll go through your questions and we'll try to engage with you guys. But at the same time, we'll also be looking at our code. And I think we're going to start with something that Jason, you had something you wanted to show, some decompiled.
Yeah. I thought as a fun experiment, I wanted to highlight a common, I don't want to say complaint, but a common reaction people have to the kind of code
that's a really good way to put it.
that you and I write. So I thought I'd demonstrate a couple of ideas first.
Cool.
So see if I can pull up screen share here.
Jason's going to share his screen there while he pulls that up. Yeah, that's a really good way to put it. A certain reaction, you get to looking at code. I don't want to say like well-crafted code, because that sounds kind of arrogant, but I guess code written by a seasoned, experienced developer sort of looks different from the kind of code you might see pop up in maybe a forum post or a standard tutorial that you might see maybe on YouTube. Not mine, of course. Yeah, just because, when you have to consider, when you're making a real project and you have to consider a lot of things, there are many terms that get thrown around in programming, such as polymorphism and encapsulation, abstraction. Those are really necessary concepts that when you really grasp them and you apply them to the code that you write, it kind of changes the way you write code and it looks like a whole different animal.
And the thing is, a lot of the stuff that, a lot of these kinds of concepts, people seem to think are unnecessary additions or sort of layers on top of software. And they think, you should be writing simpler code and that kind of thing. And so I thought I would highlight how it's not just you who's doing architecting your code, your compiler is doing it for you. So is my screen sharing there, Charles?
I'm going to pull it over right now. I had that same issue with Zoom earlier. I was trying to find it. Just had to stop my share. Yeah. Could you zoom in a little bit? It looks a little small.
Sure. So
let us know, guys, in the chat if that looks okay.
Hopefully that does the job. So this is a quick script I wrote that's meant to sort of demonstrate how I would consider most people would write scripts in Unity. So this is trying to do a number of simple tasks, but effectively, I won't bother running it and showing all this stuff, but you just have to take my word that it works. All it really does is it's a file loader. So what it does is it reads this text file, and then based on that text file, it iterates all of the columns in it. It's a CSV file, and it starts spawning waves. So it waits a certain amount of time, reads a row, and based on each element in that row, it runs each of the elements in it, and it spawns those entities. So you'll see here it basically says, when it starts, run the waves. What does running waves do? Well, it splits the list up based on lines. Then for each line, it runs a single wave. And then for each single wave, it iterates those, waits a certain length of time, and then spawns an enemy. So there's X amount of time between waves and then X amount of time between enemies. So it's doing a lot of stuff, but it's nice and kind of compact, right? Like we're looking at 64 lines of code. And this would be a common argument I would hear, because the way I would approach it would be considerably larger with a bunch of different classes and separating things out. And someone would say, why would you do that when you can write it in 50, 60 lines? It does all of that work. It does the getting the file. It does the parsing through, the timers, the spawning. All of this stuff is just nice and condensed here. So let's have a look at what the compiler has done with this script. So just as a reminder, so this is 64 lines, and it is no other class is referenced. It is just this file. So this is in a project I've called compiler experiments. And if I open this, so by default, before you build your project, it's actually stored under library, where did I put it? Script assemblies, and there it is, assembly C#. That's where your code is built to while you're running it, so that you can basically run it in the editor. But once you make a build, that same assembly C# is moved into your underscore data folder, managed, and it's the same thing. So we can have a look at now what's inside of that. So if I open up .peek and I drag in that assembly, and I'll open it here under the namespace I have and open the file, this is the decompiled version of that exact same script. You can kind of see here, file load example. Now, the first thing to note is if I full screen this and zoom in a bit, this is a lot more than 60 lines of code. Considerably more than 60 lines of code. If I scroll all the way down to the bottom, you'll see it's doing an awful lot more by the looks of it. Now, let's have a look at what it's actually doing. So if I'm going to shrink some of these sections now in a second, just to make this easier to explain. Let me just shrink a few of these. Now, this is our original class, file loading example. Internally, though, it's gone and made another class, and 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 another class. Why so many classes? Well, because that is how coroutines work. Coroutines, if I open up one of these, so I had one for start. What did the start coroutine do? Well, if I open it, it actually turns into an enumerator. And it's an enumerator of objects, which is basically what a coroutine is. And we talked about this before, how a coroutine increments over a number of steps. But what you didn't see before is it's actually a state machine. So if I go inside here, this is what the compiler did with that code. And just as a contrast, we'll go back to the other one just for a second to show you. So we are talking about only these few lines of code here. So we'll go over them in detail first. So this is just a few lines of code. It basically prints a message, waits a few seconds, downloads a text file, and then runs the waves and then prints a completed message, right? It's just these lines of code. And the decompiled version is a number of states representing each one of those yields. So you'll notice it waits for a few seconds in one state. It then loads a text file in a second state, and then it runs the waves in a third state, and it prints complete in a fourth state. So, long story short, that simple 4 lines turned into an entire class with a state machine, with a state for every single yield statement that I wrote. And because that class, in an attempt to be nice and clean and simple, actually contains quite a number of coroutines, one for running waves, one for spawning an enemy, one for downloading a file, the end result of all of that is a very large file with a number of different classes. So there's one class for starting, one class for running waves, one class for running a single wave, one class for spawning enemies, and one class for downloading the text file. So why did I go through all of that?
Well, moral of the story.
I'm hoping to demonstrate that when somebody says, why are you splitting your code up into 2 or 3 classes? Well, because the compiler is going to do it anyway. And if I do it myself, I know what I'm doing, and I can at least make it easier and readable for myself. So the idea that your code is going to be faster, or that it's that it's somehow really bad to split your code up into multiple classes is kind of silly when you realize how much of this is already being done for you. Now, this is a slightly over-exaggerated example, but the point still stands. If you're using coroutines, or you're using yield statements, or you're using tasks, the task parallel library, so any of the yield await stuff, or async await rather, it's exactly the same. All of this, it's also a state machine, also generates classes. So this isn't to say this is evil. I'm not saying don't use coroutines. Please don't take that away from the lesson. The point is that code is generating classes. There's this whole concept called lowering. And what lowering is it takes the code that you write and it deconstructs it back into something that's easier to turn into operations that can be run in IL effectively. So it's you shouldn't take it too much of an imposition to see a project split up into multiple classes. If anything, you're just doing it one step earlier than the compiler is doing it. So that's my first point I wanted to get across. And so with that, I'll turn it over to you, Charles.
You're doing something that the computer does.
Pretty much, yeah.
Let me close all this because everyone's seeing that. Yeah. All right. So with that, it's time to review some code. And again, those who are watching, I saw a couple people joining in. What we're going to do today is review some of our own code. Again, we spent the first part of the year kind of reviewing a bunch of user submitted code. But this time around, we're actually turning the lens back on ourselves. So before we dive into that, just want to say thanks everyone for being here. Hit that like button, really appreciate it. And if you could, retweet my tweet and share this where you can, just to bring some other folks in and let YouTube know that you're enjoying the content. So this is a project that I created, and this is so we created this. This came out of something that Jason and I kind of started doing a couple weeks ago, where we were just having this discussion. You're messed up in the camera. We were having this discussion about it was based on Thomas Brush. We were watching one of his streams, and we just saw how much he enjoyed working on his code, and really just having fun with it. And we were kind of musing to each other how oftentimes we get hung up in the details of our code. Being software developers, oftentimes we will find ourselves over engineering things, refactoring things prematurely, and just all good things, but really just never getting to the point where we find the fun. We're supposed to be game developers, right? So, we have to find the fun at some point. So in order to do that, we sort of challenged each other to do one game mechanic every single day. And Jason's got really cool ones. His, I think, look cooler than mine. But I made a little sheep game. That's what you see here. I made this game because years ago I promised my wife I would make a game with little sheep that would hop around. So basically, my mechanics were I would have a player-controlled sheep that would hop around, be able to hop around a map, and then whenever this sheep came in range, within range of other sheep, they would follow this one, the player-controlled one, into this pen, and then you could rack up points. So let's go ahead and just play that. It's so funny, man. It's like these little sheep. I found the fun, I think, because I spent a lot of time like positioning these little guys and like playing around with them. But we're gonna take a look at the code here in a second. But basically, you take your little sheep, take him into the pen. You can see down here, I scored a point. And we'll take this little guy in, and there I got them both in. So the game is supposed to say that I won, but I haven't done that game mechanic yet. But let's go ahead and look at the code that made this possible. As you can see here in the project, we've got this game object that represents the game, and here it takes in a list of the sheep that are available to be followed, these NPCs. And then we also have a label that represents the score label. We've got the player, of course, which is this little guy down here. He's got himself sprite render, of course, rigid body 2D for collision detection, box collider, and then the meat and potatoes that I've written is this player class, and then the sheep class. We're going to look at that in a moment. The NPCs, very similar, except instead of having a player class, they have this NPC class, and then they basically control their sheep script. And that's literally it. There's no other code. No other code that's exposed in the editor. All the other code that I have, which we'll dive into, is a lot of extension methods, some encapsulation classes or abstraction classes, and some helper classes as well. So go ahead and take a look at what that looks like. So go ahead and open up the my project here. Jason, is there anywhere you think we should start in particular from what little you know of the project?
I used to like to start at basically the entry point, right? So
Sure.
start where the code will execute in terms of your game logic, and then move to your player. So it's
Perfect.
kind of experiential then, right? Like it's how the project's set up, followed by how the player's set up, and how the kind of main flow works.
Right. So if you were a developer coming onto this project, the first thing you might do is say, well, I'll probably look at the game class, maybe the player, but I think either the game or the player class would be your first places you'd look. So I guess one thing you might notice is that here, if you look at my solution panel, I am using assemblies. So I'll talk about that later because
one small aside. There's a question there I thought I'd quickly answer.
Yeah, absolutely.
Someone was asking about the tick next to your inspector scripts. Now, here's the thing. That tick that you see in the inspector represents a script that has a life cycle. That basically is a script that is part of the Unity life cycle.
Which tick is that?
So if you go to the inspector and have a look at the actual the ticks beside your mono behaviors, the top left, the kind of turn on and off of that mono behavior.
Oh, these.
Well, it's hard to see because I'm delayed from the stream.
Oh, I thought you were looking at my. Oh, I'm not sharing my screen. I'm sorry.
But basically, my point is those ticks, they represent something that is part of the life cycle, whether it's on enable, on disable, or update or start. Effectively, if your script doesn't use the magic functions and doesn't have life cycles, you don't get the tick, and that's a good thing because you don't want to have life cycle on a script that doesn't have a life cycle. And so I actually do this on purpose quite often. If you've got 3 or 4 scripts on an object that are all intent on doing something, I try to avoid having running logic on those scripts because then you're basically having to keep an eye on the running state of 2 or 3 different things. Yeah. So for the most part, I like to have one script do logic and the other ones basically be referenced by the other one and then ran through their various steps. So for example, one script would have an update and the other scripts would have some kind of like update logic or update or handle update function that the other one would call. If that makes any sense. Oh, and on a side note, Charles, people are saying that they can't really see the inspector because of the camera.
That makes sense. Let me move that over. So we're talking about, shoot, man, I just walked through the whole thing and you couldn't even see the inspector. That's hilarious. I'm sorry, guys. I got to move those. Yeah, I guess to go through it again real quickly. You got I'm going to move the hierarchy over as well. So yeah, the main point is the game. You can see it here in the inspector. We've got the NPCs. And this is that.
Yeah, so that example being if that sheep class will not have an update method on it because it's not doing any logic. Disabling or enabling it won't do anything because there's no logic to be done in it, right? Mm-hmm. And that's all that means. And like I said, think of how much simpler it makes the entire process in Unity if more scripts don't have to be lifecycle managed. If you only have to turn on 1 or 2 scripts to do various logic.
Yep. All right, cool. So, it's fun. I didn't even know that. So yeah, the more you learn, the more you know. So that's pretty cool. I had noticed it, but I never really like dug into to figure out why that was. All right, cool. So can you? I'm sharing my screen to you, Jason. By the way,
I can see your screen now, which makes it a lot easier for me.
Yeah. All right, cool. So here's the game class. As you can see, those 2 serialized fields that I showed you guys, the score label and then the list of sheep. This is pretty simple. I guess if you want to look at the main method that has logic in it, it would be this on entered pen, and I'll show you how that gets used. But basically, whenever on entered pen gets called, it basically increments the score and then just updates the score label. And presumably, as I add game mechanics, I would probably, at the end of the game, when all of the sheeps have made it into the pen, would end the game at this point, or throw another event, or whatever I might have to do. So basically, on enable, I will loop through the sheeps that I have set here on the serialized field.
By the way, it's driving me insane.
Yeah,
sheep is the plural of sheep. It's not sheeps.
I like saying sheeps because it sounds cute, and that's what my wife says. So I'm gonna call them sheeps. I think she would appreciate it. Sheeps. It does sound pretty dumb when you say it on a live stream, doesn't it? So, and I knew that because I made this singular. I didn't put an S at the end of this, or I made it plural. But I'm not dumb. All right, so I'm gonna loop through the sheep here, and on enable, I'll basically what's it called? Register this on entered pen method to the sheep's entered pen event. And I know Jason probably wants to say something about the naming of events, but let's save that till we actually get to the sheep class. And then on disable, again, I just loop through all the sheep and I unregister from this event. And that's because if you don't deregister, unregister, whatever. If you don't do that, then if the game object gets destroyed, then you're going to have issues when that event gets fired. So another thing too is that you'll notice I'm going through this list backwards. And that's because if while we're looping through this list, a sheep gets removed, it's able to basically handle that with the way lists are set up. I can't really speak technically about that. You probably
that's actually, it's relatively straightforward if you think about it in sort of real life terms, right? If you've got 10 items on a table and you're taking each one and interacting with it, so you pick one up, interact with it, pick one up, interact with it, and you're doing it in order. You're basically saying, hand me the first one, do this, hand me the second one. If someone deletes one midway through what you're working on, they're going to say, hand me the fifth one, and the fifth one will have changed from what the fifth one would have been had they not taken it out, right?
Right.
But if you work in reverse, no matter how many they take out, the order is still the same because you're always moving it from the back down, right? Because a list is going to shift if you move the elements inside of it. So long story short, is it just like with a real list of things, is if you start moving objects in it while you're going through them, but if you're like counting heads of kids and they're running around the room, you're gonna have a hard time figuring out what they're doing. But if you start from the other end and count down, you can literally figure this out just by doing an example yourself with a few items. Try to count them forward and then move items versus try to count them from the backwards and move items, and you'll notice that if the list isn't changing shape, you're fine.
Yeah. Another thing that someone brought up in the chat was why I used an underscore. And I'm going to remove this one. But basically, the convention that I use, and I think Jason uses as well, is that when you have a private member variable, I prepend that field with an underscore. And when it's a public member variable, I make that Pascal case. And specifically the reason why I do it, and you can see it right here, is that local variables, it's much easier to tell when I'm deep in a function that this is a local variable and this is a private member variable. I can see it. I know that this is not scoped to this method. I know because of the underscore, it's scoped to the entire class. And so that's just the convention I've always used. Now, because because Rider knows Unity and is very cohesive with Unity and has all these crazy things, like I can literally see if I click on this, it'll open up Unity, and it even knows that this is a Unity event function. They recommend to have serialized fields to use, I guess, snake case. Or no, I'm sorry, camel case. And it's a little confusing because this is technically a private member variable, but I don't really look at these as private member variables because you can access them from the editor. I don't know if you agree with me when I say that, Jason, but to me, it's like it's exposed, you know?
Yeah, I guess the difference would be maybe depending on the context. In this case, I would actually just make it public. If it's not if it's in a list, it's a different story. But if it's literally something that I intend to be assigning in the inspector, I tend to make it public.
Oh, yeah?
Although, fun fact, as for the underscores, Unity will remove it automatically for you. Like if you notice, it doesn't say underscore sheep in the in the inspector, right? So Unity, I'll put it this way: it's already a bit of an indication that people will do this and that it's a common convention. If literally Unity is going to avoid your underscore specifically, but only underscore in the case where it's a public or private serialized field, because it knows people do it that way.
Yeah, it's a pretty good point. So what I wonder if you put some other symbol, it'll show it.
It will. Yeah, I've tried.
Oh, wow. That's funny. All right. So that's basically it. So I guess you figure, okay, well, how the heck does when will a sheep ever invoke this method? That's the next question, right? Because the game, basically the whole game is based on having this on entered pen be fired or triggered. So let's go ahead and look at that next. So if we go into the sheep class now, you can see here that we've got this event, and I'm just using an action here, and it takes in a sheep, which is going to be this one, the sheep that calls it. So then where does this actually get invoked? I don't know the hotkey for that, so I'm going to do find usages. And you can see in the sheep class, it gets invoked in this on entered pen. I don't want to belabor this, but basically this is just like a helper method so that I can, if this happens to be null, if no one has ever registered to this, I can just use this null, forget what it's called, the no propagation operator or something like that.
No coalescing?
Yeah, no coalescing. That's what it is. You can use that to invoke it safely. But basically, I call this, the sheep calls this whenever the on trigger enter 2D is fired. There's nothing fancy here. Again, we're trying to do one mechanic a day, so it was like just try to get it as easily as possible. So you notice I'm not checking for some sort of tag of the pen. Basically, the only thing a sheep at this point in time can collide with is the pen. So that's the only thing I check. So basically, this whole mechanic depends on the sheep being able to move. So it's like, okay, well, how does a sheep move? Well, if we look through the structure of this class, you can see we've got a couple of public methods, or actually, there's only one public method, and it's called move. So this is the only thing that really is accessible, and this is the one thing that actually moves the sheep. So really, apart from looking at what this code does, the next question is who calls move, right? But just to let you know what this does, all this does is when move is called, it does a do tween. It does a do jump on the transform. So if you're not familiar with do tween, it's a tweening library, and it happens to have a whole bunch of methods for tweening things like scale and position. And there's a fun helper method called jump. And literally the jumping that you saw earlier with the sheep, this does it. I don't have to do anything fancy. And of course, I need to make sure that I don't allow move to be called in the middle of a jump. So I just have this is moving state variable. It's a Boolean that just says, hey, look, if you're in the middle of moving, just return. This is called a guard clause. Otherwise, we're going to go ahead and just do the tween. All right, so that's that. So then you might ask next is, well, who calls move, right? So let's take a look at the usages here. We can see that the NPC calls move, the NPC class, and also the player class. So the player class, that's pretty interesting. I'm curious to know how the player moves. Let's click on that. If we click on that, we can see it's very simple. There's nothing to it. There's literally only an update method and an awake, and the awake is used to initialize sheep from the scene, which I don't really need to do. I could probably just make this a serialized field at this point because I'm not doing anything dynamic. I'm not loading sheep or the player at runtime, so I could conceivably make this public or a serialized field. But basically, in the awake, I create this move vector variable, and I just update it based on WASD. And based on WASD, after I collect that information, if move vector is still 0, I'll just go ahead and return another guard clause. Otherwise, I'm gonna get a direction. There's this object called direction, and it's just called direction from nearest from vector, which I probably need to rename.
Finally gotten to there's a question specifically asking about that direction class, so I was waiting till it got here for you to dive into that one.
So I think I need to rename this because this isn't very clear what this does. But basically, the direction class supports your cardinal directions, north, south, east, and west, as well as northwest, northeast, southwest, southeast. And how you get a direction, the easiest way is you just pass in some sort of movement vector. It could be any vector. And based on that, it's going to tell you what the nearest direction is based on that vector. And that's what the sheep class uses to move. So if we go into the move, you can see that the sheep basically uses direction here to figure out what the destination is. So why don't we look at that? If I go in and click on direction, this is a class that I made, and all this class does, its only job is to encapsulate directions. Again, if we scroll down to the bottom, you can see I've already hard coded them in here as static read-only variables: north, south, east, west, northeast, southwest, southeast, southwest, and then none. And really, all these do is represent vectors. So you can see that if you scroll to the top here, we can see there's a private member variable here called vector, and it basically just stores what vector does this direction represent. And I think a good way to understand this a little bit easier, or an easier way to look at it, is if we look at my unit tests. If I go into my my unit tests here, and I have one for directions. Where is it? There it is. You can see that I have tests for each one of these directions. So for instance, none. If I call direction.nearest from vector and I pass in the vector 0, 0, 0, I expect to get direction.none. If I pass in a direction here, so here the x is 0.2f, and then 0.8f. So if you were to try to imagine that, it would be a vector kind of pointing up and to the right a little bit. I expect that to return the direction north. So as you can see here, the idea is I might be passing all sort of movement vectors, and I can't guarantee that they're going to be perfectly on 0, 1, 0. You know, they're just going to be somewhere randomly in space. But I just need to get some vector that represents north, south, east, and west, all those cardinal directions. And that's basically what this class does for me. So we don't really need to dive too deeply into it, but basically, you know, in my nearest from vector, I do a normalize, and then I do a vector.snap2 and a vector.round, which people may ask what those are, and those are actually extension methods. But basically, once it gets that, it's just going to pull from my list of hard-coded directions. It's just going to get the first one that matches. And it should, if it doesn't find any, return none by default, although this link expression doesn't work. I don't think I understood this correctly. This actually throws an exception if it can't find it. So basically, if we go up, I guess there could be value in showing extension methods. Or do you think I should move on, Jason? What do you think would be easier to follow?
Yeah, if you like. I mean, I've got some extension methods too, so I guess it might make sense to cover the topic.
All right, so basically, for those of you who don't know what an extension method is, I can basically add methods to classes that already exist. So if I go into the snap2, you can see that there's this, basically we scroll to the top, we just minimize all this so it's not confusing. We've got this extensions class. It's static. It has to be static for an extension. And then I've got these other static fields, or rather methods. Let's look at the snap2 one. You can see that it takes a this vector3 vector. And what this allows us to do is to call vector.snap2. And if we go back to direction, you can see I'm calling vector.snap2, and vector is a vector3. So I basically dynamically added my own method to vector. And I'm not going to, I literally copy and pasted this off of Stack Overflow, so I don't really know what it does, but I can tell you that it snaps to an angle. So I'm just snapping to a 45-degree angle, and then round as well is really simple. It literally just rounds each of the X, Y, and Z's. So that's what that does. Okay, so pulling up, back up into player, that's it. It gets the direction based off of that move vector, which we know will be based off of your WASD, and then it just passes it into move, which is all of the logic that we already just looked at, and it just moves the sheep. So it's pretty simple, and hopefully easier to read. And like Jason showed us in the beginning, there's a lot of classes, you know, that like I got the direction class, I've got this extension class with these methods, these weird methods that don't exist in Unity. You know, someone might look at that and be like, whoa, my gosh, this is way over engineered. But I'd argue that it reads pretty nicely, except for this. I got to rename this. Otherwise, it reads pretty nicely, and it's fairly simple to follow. So I don't want to toot my own horn, but that was the idea. All right, lastly, the other thing we'll take a look at is the NPC. So we'll take a look at what that is. So, okay, the NPC has access to the player. It has access to this min-max, which is a custom class. I'm not going to go into that. But basically, it represents a minimum and a maximum value that you can set in the editor. And that represents follow distance. So that just allows us to say, hey, when do we want the NPC to start and stop following? So the min would be how close the sheep will get to the player, or rather how close the player has to be to the sheep before it begins to follow. And then the max represents when the sheep will stop following the player, or maybe it's vice versa. But you get the idea. All right, so basically on update, it's just going to check, hey, am I within following range here? If I'm not, it's just a guard clause. It's just going to say, okay, I'm not going to do anything. If it is within following range, and I'll talk to you how I do that, if it is within following range, it basically gets a move vector based off of the player's position and this NPC's current position. Then, again, we saw the direction. It just gets the nearest direction from that move vector, and it calls sheep.move, and it passes that in. And that's really all that there is to it. The more, I guess, complicated logic here, it's not really that complicated, is figuring out if you're within following range. And again,
by the way, this is a small aside.
Yeah.
This is one of my favorite little concepts, and I think people don't do this often enough. is the actual line of code that's being ran here on line 25 is the one on 36. Now imagine that if statement had read if distance from player greater than or equal to follow distance dot min and distance from player is less than whatever. Like that, it's still readable, but the problem
like
is,
that.
yeah, if someone was to ask you what is it doing, the answer is it is checking if in follow range. And there's an interesting concept of how much mental energy you're putting in through of reading someone else's code. And you didn't think about it when you read that. You said, oh, if not in follow range, I get it. Because you didn't have to parse it. You didn't have to sort of reason about what it's doing because Charles wrote it down and then named it. And it now became if in follow range. And it may seem like a subtle thing, and a lot of people get a bit squirrely about sort of almost arbitrary separating things out. But if you were to just see this for the first time, you would have to kind of give it a bit of an extra thought and pause your way through it. But a lot of writing code like this lets you skip that extra step of having to sort of reread the code in your head and try to figure out what the result would be. So it's a small thing, but I wouldn't take it for granted, right? Like read this code as think about how easily you read it the first time. If not in follow range, and then you just moved on. It's like you didn't even register it being a thing because unless you need to change that algorithm of what it's doing, you don't need to open it. And that's kind of a running theme with a lot of the clean code architecture stuff we're talking about. Unless you need to open it to change it, or it's broken and not working as expected, the name should tell you what it does, and you should be able to move on with your life just by reading the one statement and moving on, right? So complicated if statements is one of the biggest examples of this I see from people. They'll do if this is not null and this other thing, and then this other thing is true. But realistically, what they're saying is if standing in the right place, or if has collected the blank. And that if you just write that statement, then you don't have to try to decipher the code, you know?
Yeah. The technical word, I guess, for that would be self-documenting code. And really, that's the importance of it. And you really want to encapsulate these concepts so that so it's human readable. You need to be able to step through the code. And this is something that really, for me personally, clicked when it came to writing unit tests. Just because, when you are trying to, let's say you have a whole bunch of unit tests on a project and something breaks, likely it's going to break on something that you haven't touched in months. So if you have to go and all of a sudden look at a failing test and understand what happened, the best thing you can do is make sure that that test reads as clearly as possible. So you understand exactly what the expected behavior was so that you can understand what broke and go and fix it. And that's something that, I think that's what really made it click personally for me.
Yeah, and for me, there's a really interesting statement made by Uncle Bob, which I think really kind of clicked for me, which is if I was to ask you what the point of writing code is, you'll probably say to make it work, right? If I gave you a challenge, make the code do X, make a character who does this or who moves this way. If you make your number one goal, making the code do the job that was asked of you, you might succeed. But the one constant in software development is change. Mm-hmm. Whoever asked you to write that code will change their mind. It could be a small change, like change the numbers or move it over here a little bit or change the target position, but it will change at some point. It almost always changes no matter what you're writing. And so if your goal first and foremost is to make it work, then the second time you come around to it, you're going to have a hard time trying to figure out how to change it or modify it. If you switch that and make your first goal to make it read well and to make it make sense, even if it doesn't do what it's supposed to do, and you get a change or you get another requirement, then the fact that you can read it easily, see what it's doing, and see where you'd have to change it is actually more important than if you wrote it the first time around to do what it's supposed to, but it was hard to read. So it's a weird thing to describe, but making your code easy to understand is actually more important than actually getting the code right. Because if the code's easy to understand, it's easy to understand the change to make it right. If the code is right but hard to understand, it's hard to change the next time you get a new requirement. Yep. It's a weird concept, but it really changes the way you approach your design.
And that I understand why some folks don't really get it. It's because when you come from the worlds that Jason and I come from, where we've worked on projects for many, many months, you get to see that change. And more importantly, when it's not your own project, when it's your boss, or if you're a contractor, your client pushing those changes, you don't get to say, I don't want to do that. Changes will come in and you have no say in the matter. All you can do is make the changes. And the best thing you can do is have your code flexible enough to first understand, because likely these changes are going to be about, again, some feature that you haven't worked on in months. And you're going to have to understand what that is and make the change. And typically they're under a time crunch, so you have that
Mm-hmm.
pressure too.
Yeah, like if you just to recap on that in follow range, if someone came along and said, "Oh, previously this happened if in follow range, now it's going to be if near this post," and
Yeah.
you're basically changing it to the new algorithm of if standing near post. If you were looking at the previous if statement, you'd have to go through and go, "Wait, which part's the distance check? Okay, I take this bit out and I swap it out." Now you can just remove out the one that says in follow range and put in a new one called standing near post, and then you can write whatever that particular statement is
Yeah.
because it's very clear that that's where that line would change.
I mean, even when I was trying to describe what follow distance was, I couldn't even remember, and I couldn't even think here live which one was which. I still don't even know how it works. I don't remember how this works, but I don't need to know how it works. I just know that it does, and I know what it does, most importantly. If this wasn't an if statement and I was here on stream, even today, I wrote this last week, I would likely be like, and this, I'm pretty sure, just make sure that the player is close enough. I wouldn't be able to tell you what really, in so many words, oh, it's with it when he's within following range. That's super important. I mean, I have a terrible short-term memory. So for me, that's like incredibly important. It's funny. I saw 3 comments about this, by the way, and I pulled it up. People were asking about the font. This font's called Victor Mono, and yes, there are ligatures. I see that.
And I hate to break it to you guys, I also use ligatures. So you'll be seeing some of those when we switch to my code.
Blake is like, gross. What do you think? I thought you didn't like ligatures for a while too.
No. I love ligatures. My question was which font I was using, but I'm a big fan of anything which minimizes code.
Yeah.
It may be an unpopular opinion, but as far as I'm concerned, again, the point of code is readability.
Yeah.
And people may not like it, and maybe there is a little bit of an extra mental jump that I could argue I can understand why you might get rid of it. But as far as I'm concerned, this is my font that I'm reading, and it simplifies the amount of characters on my screen. So for me, it's perfectly fine, Yeah. If I was giving code to someone else, maybe I would actively not use ligatures when handing them examples. But yeah, I like it. It makes my code smaller. I can easier parse it without having to kind of, have all the extra characters and that kind of thing.
Yep.
But again, it's stylistic and preference, It's not important in any way, shape, or form. It's purely a design choice.
Yeah. Sorry. All right, so that's that. I mean, there's really nothing else into my code. I guess the other thing I could show is the test. What do you think? I guess I can show it. Or I can. I just want to really quickly. I'll touch on one thing. I'm not going to dive into the test. I just want to touch on one thing. I made a video on assemblies, and I just want to show you that even I made a video on them. I do use them. I don't just. I just want to make sure they are practical, and I want to show you.
Oh, well, my example has assembly definitions for everything, so
perfect. All right, so basically that's it. There's assemblies here. We have a scripts assembly, and just the way that I have my tests here, I have edit mode tests and play mode tests. So you can see that actually here they are on the right hand side. That there are tests, and I actually already showed the test, so it's not a big deal. Yeah, I think we're good. I'll go ahead and switch it to you then. No.
Cool. So I guess I'll demonstrate my code. So the first thing is, Charles, I won't be able to see the chat because I've only got one monitor at the moment.
Okay, no worries.
Another one is on order. So in the meantime, you're going to have to read out any messages that come through that have questions about my code as I go.
I'm sure you'll be talking, so I'll pay attention to the chat. Have you shared your screen yet?
I have now.
All right, hold on. It's going to mess up my whole stream setup. Shoot. 1 second, guys. Bear with me. Probably there he is. All right, I just want to make sure you are still showing up. All right, I'm going to switch over to your screen.
Cool.
Remember that right hand side where your inspector is. Our faces are covering that.
Oh yeah, good to know. Good. Thanks for reminding me. I might have to do some jiggering myself. Let me just move a few things over. The only thing I'm really caring about in this particular context is mostly the console anyway.
Yeah.
So I'm going to start with what my challenge to myself was. So rather than just show you the code, I'm going to work through the task I gave myself and what I was attempting to do. So the first thing was, let me start with a very quick prefab I have here called generate log messages. It's a really simple script. You don't really need to focus on it too much. We're not going to go over anything in vivid detail. It's literally just a number of keys, number of messages, and if you press the button, it writes that message. It's a test script, throw away, we'll move on. The only reason I'm mentioning it is when I run this project, And it's an empty scene, by the way. This is the only object in it at the moment. The point is that when I press the 1 key, I get a log message. When I press 2, I get a warning message. 3 is an error, 4 is an exception, and 5 is an assert. These are the default messages that Unity logs provides. Now, the task I gave for myself is I wanted to see these at runtime. I wanted to be able to visibly see what logs are happening. So I did a bit of research to figure out how to do that. Now, the short answer, let's see if I can pull up. Generator, let's do no, I'll do a quick script to demonstrate. Log listener.
Sorry, I'm quiet. My job was trying to reach me. I'm just trying to answer some work stuff right now. Apologize.
Yeah, it's all good. I've got enough to go through here at the start. The computer will catch up. Right, so first thing, the challenge is, how do we listen to logs in Unity? Well, if we do the standard debug.log, there's all of these different log functions that are log assert, log error, log exception. And what you can do is you can listen to these by listening to an exception for, I think it's application. There's an event here somewhere that'll tell you when there is a, yeah, here we go, log message received. So you can subscribe to this event and get a string message for whatever happens. That's fine, but the problem is the object you get back, do a quick one here. You get back string conditions, string stack trace, and the type of log message. I want a bit more freedom than that. I want to sort of play with the ideas. So the other way to do it is, and this is a good example, we talked about the whole point of software architecture and encapsulation. Well, Unity have already done this for us, and it's done a pretty good job. If I was to say debug.log, and you saw those messages being printed, that's just this function printing those messages. How is it doing it? Well, it actually uses this object here called a Unity logger. And Unity logger is a interface type. And it's literally this interface. And it does a bunch of things. Now, I don't want to focus too much on this. I'm just pointing out this is literally how Unity is handling its own internal logs. It's got all of this stuff. All that really matters, it's got a log function, and it does various things with that log. And then it's got this thing called a log handler. So something is firing a log and something is handling that log. Now, Unity lets you provide your own log handler. So if I wanted to, I could do something. Public class, my log handler, the log handler, and provide whatever code I write in here, I can assign it as this project's current log handler. So Unity logger, log handler is equal to my log handler. And now if I was to run this, all of those logs wouldn't go to the console. They would instead arrive here and arrive here. And I could choose how to handle that. So that was my first challenge. But the problem is I am overriding the existing log when I do this. So it would be much nicer, rather than overriding the existing one, if I could add new logs outputs as well as the console. So that's what I did, and I came up with something called a composite log handler. And a composite log handler, at its core, is just a log handler, which is also a list of log handlers. And what it does is it iterates its own elements and sends it to each of those output sources. And Charles was talking before about extension methods. Well, I'm using an extension method to make my life easier here too. So what I can do is I can say debug.unitylogger.add log target, and I could pass in my own log targets. Now, I've got a few of these pre-built. So this is an example. We could say on text, and this method will now get called with just the string that represents what that log target was. And I can effectively demonstrate this by doing a quick text area. And don't worry, we're getting to the actual code review portion. I just want to demonstrate a couple of things first. Because if you understand what it's doing, you'll understand the reasoning of where I got to the decisions I made. So all this does is listens to the logs and then outputs that to the text. Now, let's see if we can give this a run. And you'll see this text area. And this text area, if I run, because my log generator is generating logs, if I press 1, I get hello world and a few other different messages. So these are my straightforward logs being received to the text view here. So that at the core is the intention of what I'm going for here. But I want something a bit nicer than this. So I'm going to try to step through where I got from here to there. So let's have a look at the code. So on here, I've got this add log target. What is that doing? Well, there's a whole load of stuff going on here, but basically I'm extending the existing logger and I'm adding a new log target. And what I'm doing is this composite handler is taking in whatever handlers you want, and it's checking if the existing one is a composite. And if it is, it adds a new log handler to that composite. If not, it takes the old one, makes a composite, hands the original one to the composite, and adds the new one to that list on top of it. So long story short, this replaces out the existing handler with a composite handler, and then I can add as many sources as I like. And I'll demonstrate that by doing a few more interesting sources now that we have the basics in place. So if I go over here, I can demonstrate how I've gone from just printing it to on text to I could print to different sources. So I can say, let's go with TextMesh Pro. And it's hard to do everything backwards because I've moved all of the places in with the text.
Yeah, it's weird.
So I really want to highlight here that I'm not just arbitrarily kind of going through this in steps. My point is this is literally the order I approached it. I want to capture the logs. So step 1, how do I capture logs? How do I test it? Well, I'll just throw the logs into a nice little text box. I can see that it works. Good. What's the next step? I want to show those logs in something more interesting like TextMesh Pro. So if I go back to my log listener here, I can add a TMP text, and then I could add another source. Add log target, and we're going to add that TextMesh Pro. So if I have this one set up. Oh yeah, I have to do a TextMesh Pro source, don't I? I don't want to complicate things. If I go down this road, I might be, I might pause here for a second. I'll cut to the end because if I go through this, it'll be like 12 more steps. I'll just demonstrate how I ended up getting the end output out, which is this will compile. So I have this idea here called a full screen console. Drop this in. We'll get rid of him for now. And yeah, we'll leave him there. Why not? So if I run this and I press tab. Oh, do I have my controls up and running? I don't. Let me see. What does it do? Console in and yeah, there we go. So if I press tab, I get my fading in and out rectangle, and then as I type, I get the log messages appearing. So you'll see how this is just an incremental step above the next one. I'll show you the code now in a second for how I got to this. But effectively, this is the same thing. It's just displaying the console messages here. So let's have a look at what that's doing. So I have this thing called a console. And what is a console? Well, a console, if we shrink all of the elements down and simplify it. So first in the inspector, you'll see it's a number of parts. The first one is what does it need? It needs a UI. We'll get to that in a second. Formatter we can leave out. That's a configuration. And it's got 2 options. Listen for Unity logs and hide on start, which it hides on start. And then I have this controller which controls that log by basically handling the input. It's really straightforward. It takes in a console, chooses a key, and depending on that key, it either clears out the log or shows and hides it. So back to the console. What is a console? Well, at the core of it, all a console is an add line. It's a thing that can receive a line to display. And in our case, we know we're going to get those from the Unity logs, but you could provide different other messages. It doesn't have to just be the Unity logger. So I'm doing the same thing that you saw earlier. I'm making a handler, but in this case, I'm making a console handler. And what is a console handler? Well, it's the same thing. It's a representative of the iLog handler, only it takes in this thing called a console, and then, depending on formatting, passes those messages to the console. So I know I'm going through this quite fast. Are there any questions or any comments in the chat, Charles? Okay, I'll keep going for now. So
yeah, sorry, I'm on a quick work call. Just it should be quick.
So yeah, so basically this is the console, and you're seeing the logs written out by this handler. Now, the first thing I want to point out here is I started out by getting the logs and I moved on to having this console. But I want to highlight how there's no UI here. There is this thing, you can ignore it for now. But the point is, what is a console? Well, a console is a thing that listens to Unity log events. And then on receiving those messages, it has this add line and it does something with that line. And in this case, it adds it to a string builder and updates the UI. So this is an atomic unit of work, right? There is a thing which reads log messages, does something with it. There is a thing which receives strings, does something with it. Attach one to the other, you now have a thing which takes log messages and displays them. And because this is a separate entity, if I have a look again at this UI, this UI is just the other end of it. It's this fading in and out portion. We can open it up, and it's really straightforward. It is a UI console, and it requires 3 components: a label, a canvas group, and a scroll rect. And then its visibility, well, it fades in and out, the canvas group. And for displaying it, it displays it on a Text Mesh Pro. That's the only 2 things it needs. And in this case, this on display changed. It just changes the scroll of the scroll view to move it down to the bottom whenever there's a new message. So it's quite small, and it's obviously extending from something, so it extends from UI console. And if we go back one more level to UI console, it's not that complicated either. All this does is it has some form of display where the text goes, and it adds text to it, or it sets the text, or it clears the text. So in this case, that display is of type Text Mesh Pro. It could be Unity text, it could be a text file, it doesn't matter what the source is. The console is going to take the text given to it from some source, which happens to be the existing console, and will display it into this console, which happens to be on a Text Mesh Pro. And if nothing's provided in this case, I am doing an empty display. So this is a null object pattern, which is effectively guarding against nulls. So you'll notice I'm not doing null checks. This one line lets me avoid null checks because all it does is if nothing is provided, it gives me this empty implementation, which doesn't do anything. And that way I can ensure that in the worst case scenario where nothing has been provided to output to, it will instead just not output anything. So, so that's the basics of how this works. But the bit that I want to really focus on here is this is one implementation. So this is a full screen console. That's the kind of name or the intention of this particular console I made. So if I was to run it, and I'll show and hide it, show the messages, I can scroll up and down, but that's just one implementation. And as I've said before, the goal of good software architecture is to isolate things that change and change together. So this console is a design choice. I wanted it to be a full screen console at the time, but then I could change my mind and say, you know what, I don't want a full screen console anymore. What I want instead is a drawer style console. So if I drop this drawer style console in, and I have this console object, it needs a UI to run. So I pass in this drawer UI as a console and run it. It's exactly the same, only this one slides in and out rather than fading up and down. And it's the same thing. Scrolls, shows messages, I can clear the messages, I can write more messages. And it's all coming from the same sources. So how does that work? Well, does it look drastically different? Is it much more complicated? Well, let's have a look at the drawer console. So in this one, it requires a label and a scroll rect. The visibility is using this thing called a console slide, which slides in and out. And the display is a Text Mesh Pro again, but it could be something else. And so you'll see how I've isolated the parts that change. A console is something which shows and hides and has a display source of some kind. And then the console logic is the thing that kind of marshals the incoming data, displays it onto the display, and decides whether or not to show the console. And these are all just animation properties for how long does it fade. And you'll notice there's a couple of things like the text will fade at a different rate than the console itself. But it lets me just tweak all of those visuals without worrying about the logic. And I'm not going to break the console logic by doing anything here. And on that note, what if I want to get fancier? So I can have this drawer, and what if I decide I want to change the formatting of the text? Because let's be real, it's a bit boring, right? Like at the moment, I'm just displaying plain white text. So if I wanted to format this, I would want to handle that regardless of which kind of displaying console I'm showing. So, and by the way, I don't know if that's actually showing, so that's just the scroll bar version of the console, just in case it was hidden. So what if I want to change the formatting? Well, I have this thing over in the console object. This is the non-UI portion, this is the main logic for the console, and then this is the thing that controls how it works. Well, it takes in another object called a console formatter. So what if I want to provide a standard console formatter? And if I drag that optional parameter in and run it again, and I'll move it again so it can be seen, you'll notice they're now changed different colors for the log messages, because that is a choice that is built on the console. It is not a choice on the UI, right? The fact that I want to format the strings a certain way is a different conversation than how I want the actual console drawer to work. So I've isolated myself from the changes of if I want to keep one or the other. So for example, I can go back to that. I can drag in our full screen console again, and I will assign that one as the new one. And he gets the same messages, right? Because they're completely different. The fact that I want to format the text is a different conversation than the fact that I want to display it in a particular way. So now that we've established that, we can change again which particular order we want to do some of these things. So let's go with, I'll put the drawer back on because I like the drawer. And you know what? I'm going to actually change the drawer around too. So I'm going to grab the drawer and move it to the left side and change it to a left. Turn off the full screen one. See if this still looks okay. Yeah, there we go. So again, these are all like cosmetic decisions, right? They shouldn't affect the data. So now let's have a look at those console logs. So at the moment, I'm logging them with this sort of colored thing that shows the time. If I clear this out, I can choose instead of time to show a simple character, simplify it, or I can show a log type. And that's sort of the more longer form message for what the log is. Now, it doesn't matter which formats I've chosen here. My point is simply the fact that I've made those separate decisions. I can go in here at any time and change what the colors for my logs represent globally across my application without worrying about which log under which context I'm currently showing. So let's run that again. And now they're kind of a little bit easier to read, right? So that covers the basic concept of the logs and log formatters. Oh, and by the way, it doesn't just have to be text changes. If you're thinking, well, that's a bit simplistic, you're just changing the colors. Well, TextMesh Pro has some interesting stuff in it. One of my favorites being the fact that it actually uses a sprite reader for if you're doing things like emojis. You can actually do something like if I do this, pass him in. Don't know how well this is read. I don't have my spacing done correctly, but if I run this now, yeah, here we go. So you've got little icons that represent the messages as well. And to be honest, I'll probably get rid of the full name. I'll go back to character for this one. Yeah. So there we go. So I've got these little icons. And the way I'm doing that is it's a formatter. So if I open up this log formatter, it's not massively complicated. It extends from the standard formatter. It's called an icon formatter. And it uses this sprite syntax, which is how TextMesh Pro deals with sprites. And then I pass in the index for the sprite I want, and TextMesh Pro handles its own rendering. So if I was to open up that text, there is a concept in here under TextMesh Pro, extra settings, called sprite asset. And that sprite asset represents a table of the icons you're using. That doesn't really matter. I don't want to get too down the rabbit hole with that. All I'm saying is the decision to use icon-based sprites in my console is irrelevant from the decision of what kind of drawer or style drawer I want to use. And as a last note on this, I've been using these sort of drawer style consoles, but they don't have to be a drawer, right? The point of this is that I've isolated the generation of events for logging from the visual representation I'm choosing. So in this case, I've got, where is it? Oh, notification, let's go with that. So if I do this, and I might get some errors for that one, but we'll come back. So if I press 1, I get this thing, log hello world. If I press 2, I get a warning, it'll fade away, 3 for error. And this is just a notification display. It's effectively the same idea. It's listening to the same events, it's subscribing and doing the same work. It's only I've decided this will only show me the latest event, and it'll show me whatever the message is. So I can have a look at that script to show it's not that complicated. At the end of the day, it's a UI element, and that's how I do all of the sliding and animation and stuff. All it does, it requires a canvas group. The visibility type is a fading of that canvas group, and I set whatever the message is, the color, the text, and the title, and that's all it does. And again, notice how this is a separate. This is the UI portion of the notification pop-up. This deals with how it renders, just nice, how it visually displays. Separately from that, there is this concept here, which is the actual notification, and it does all of the kind of the bulk of the legwork. What does it do? It subscribes to the Unity events, and it tries to format it using the existing formatter. If not, it just provides an empty format string. So in the same way I did with the console, I can decide on this notification pop-up to choose a different formatter for it. And it would, again, display with whatever icons or particular colors I'm using. Now, why did I go through all of this and demonstrate it? Well, my point is, I incrementally went through these stages, starting with my goal is to build this UI console. But what's the first step? The first step is how do I get those log messages? And so now that we'll go through the different stages, I should also mention, as Charles pointed out in a previous video, these are using assembly definitions. So if I go into my scripts directory down here, might be a little bit hard to see, I'm sorry, but these are the portions of my application. This is the common library, and actually I'll show you each one what it's referencing. Might be interesting.
Someone Blake also asked about that require method. I don't know if you went over it. Sorry.
Oh, I didn't actually. That's a good point. But yeah, the require method is a small extension I added that I find it makes my code a bit cleaner. So just to highlight, personally, I don't like. I used to use get components and find objects of type, but what would happen is you're basically saying when I run my application, do a bunch of logic, right? You're saying before my application runs, start wiring up a bunch of stuff. And that's like sort of setting up a movie ready to play, but then not putting all the wires together. And then just before the movie starts, plugging in all the wires. Like you're adding work on what's supposed to be the presentation. So what I prefer to do is give myself editor warnings that stuff is going to happen. And it's my job to hook it up. So in the case of if I don't provide the UI to display for this console, I'll get a bunch of messages and a bunch of errors. But the important one will be the top one. And the top one says missing object of type console. And if I click it, it'll ping the object in the inspector and I can see what it is. So this isn't meant for runtime. This is meant for me as I'm basically testing to say, you forgot to drag in that object. Because if I drag it in the inspector while I'm working on my app, the application doesn't have to go and acquire a load of stuff or do a lot of logic, right? In these kinds of small contexts, it just makes sense to drag it in, make prefab out of it, and it does the job you need to do. As for how it's doing that little message, it's really straightforward. It's an extension method, just like Charles indicated earlier. And all that this one does is it just prints a message. Now, it's using generics, and I don't want to get into generics. It's a whole different conversation. All I'm saying is this require function, excuse me, will automatically append itself to anything which extends Unity object. So any object I can just sort of grab, let's see, that console.require. And it can do that because the base type follows that chain. And I don't know if I mentioned that before, but if I go mono behavior, and if I go down and reflect down into behavior, and go down again into component, and go down again into object, this is the object I'm attaching to. This object here, and it's the thing that all Unity types extend from. So that, all the way back up, is, where did I put that extension methods, validation extensions? So it's basically saying get any type where it is of type object. So that's all that's doing. And then I just print a message. And I print a message, I just add a bit of color, yellow is missing, and then blue is the type of object in the context. So that lets me know what object it was on what script. And a lot of people don't realize this, but that those normal debug messages, so the default debug unity.log, that last parameter. So you can just write your message, or you can pass in a second parameter. And that second parameter is the context with which this exception happened. And if that object is of type Unity object, you'll get that nice ping in the inspector, which is what you saw me do. So you can do that yourself. Any object which you pass in as that second parameter, if you look over here on the inspector when I run this and throw the error, I click it, it does a nice little yellow ping. So it's a very good indicator that this is the thing that had the error attached to it. So yeah, I hope that answers the question. Right. So where was I? I was
like assemblies.
Oh yeah, I was actually going through the actual code. Yeah. So now you've seen what it does and how it works and whatever. And again, I want to highlight that this wasn't my end goal. I just got to this architecture by incrementally stepping through it, and I'll show you kind of how I got there. So I started with the logging problem, and this is a logging assembly definition. What does logging need? Well, logging references the common library and the UI. So it kind of, let's have a look what's in common. Well, common doesn't reference anything. Common is like all it is, just the common library. What's in there? Well, it's that validation exception you saw earlier, and it's got this color extension. And all that does is it converts a color to a hex value and vice versa. You can basically, you need that to do some of the printing stuff. So these are the common functions. And then on top of that, we have the logging. So back to logging. So I talked about handlers, right? And if I go to the handlers, there's only two of them. There's this one here, which is an implementation of that log handler. What does it do? Well, it takes in some text to send it to. It takes in some format that you're going to display it as. And it basically says, if you haven't provided a formatter, use the default one. Otherwise, use the formatter provided, and then log the message. Append to that text the formatted version of the string that comes in. That's all it does. And then a composite composes a load of those together, as I showed earlier. So these two things together are not massively complicated. One of them basically says, take in some source to send text to, take in a format it, send it to text. What does the composite do? Takes in a bunch of those, iterates through them, displays them. And so that's all handlers do. Next up, formatters. What does a formatter do? Well, let's have a look. Log string formatter, it's just two functions. Logs the string, either as an exception or logs the string as a log. Now, this is the exact contract Unity uses, so I just mapped to theirs. I just added my own wrapper so I could provide different formatters. And as for what different formatters I have, well, I have the no formatting, and that just displays a plain string, no date time, no colors. It just literally prints the string. Then I have the slightly more advanced one, which will color the entire string. How do I do that? Well, I just color the message. So I take the message, pass it into the colored message, and I pass in the argument for whatever colors you're going to use. And that's all this does. It wraps it in that color tag, which is how colors are displayed, either in console, in the native console, or in TextMesh Pro. That color tag will work. And then there's other ones too. I've got this one called a prefix formatter, and it's basically chooses which prefix. And you saw that earlier. It either shows the time or a prefix character or the type of the log, and that's just different prefixes. The point is none of these matter because they all conform to that contract, and providing I conform to that contract, I can just not use this one. I can just completely try a different one whenever I want. This just happens to be the one that came to mind. And the only reason I have a number of them in here is because as I went through this process and changed my mind a few times, I came up with different formatters. And that's kind of the whole concept behind open closed, right? My code is open for extension. In other words, I can keep adding whatever I want to it, but it's closed for me to actually edit the code, right? Because I'm not opening the file every time to change the results. I am extending my code by creating different formatters, but it's closed for modification. I'm not actively changing it, right? So that's formatters, handlers, and then there's just color stuff. That's just sort of a nice little bit of helper so I can see in the inspector. Doesn't really matter. It's just, I've got a bunch of presets. So I can say log colors.soft or .nicer or from different colors or from hex, and I can basically build a set of log colors. Just a helper class, really. And then there's the color picker, and that's just a version of that log colors that serializes in the inspector that I can then pass back and forth. There's a reason for it. Doesn't really matter. It's just for cleanliness sake. So my point is this folder here is all the logic for logging. And it's one thing. And if I don't want the console and I don't want the whole multiple text source thing or any of the other animation stuff I did or the UI fading, I don't need that. I can just take this one. I can just take that logging folder. And it only depends on two portions at the moment. It depends on common and UI. So they're the only two other sets of scripts I would need. And because I'm using assembly definitions, I can very clearly tell what's the hierarchy chain of these different scripts. I'm not going to accidentally need to pull in other random stuff. I know it's only going to be these two other folders. Let's have a look at UI, actually. Let's see what's in it. So UI has a couple of things in it, mostly to do with that visibility stuff I showed earlier. So I won't go too far into this because we could go down a massive rabbit hole. All I'll say is deciding how an object, specifically say a UI element, shows or hides is a completely different conversation than the fact that it does show and hide. So the contract that I'm using, and you saw that in the other different UI elements, it's just this. There is some means with which this object is going to show and hide itself. And this is all it is. Shows, hides, is it showing? Hide it instantly. In other words, don't animate, just hide it. And then initialize any object you might want. And because it implements iDisposable, it has a dispose function for clearing any resources that it would have used in the process. And just as a reminder to show you how that looks in actual code, this is the visibility. It's currently a canvas group fade. And in the background, it's just doing this. It's literally saying, take the current visibility. If there's none provided, use no visibility, and then show it, hide it, and toggle it if it's requested. So that particular implementation is just one style. And if you're wondering what the implementations look like, here's a few very simple ones. Turn off object. What does that visibility look like? Well, I take an object and I set it active to show or false. That's pretty self-explanatory. What if I didn't want to turn off an object, but instead I wanted to take a maskable graphic like an image and turn it on or off with its alpha? So that's what this does. It turns the alpha on or off. Now, these are all pretty blunt. These are just like flicking stuff on and off. So I decided later, you know what? I want to add some animation, but I don't want my visibility system to depend on DoTween. Because if I do that and I give it to somebody else, I'm enforcing that they use DoTween too. But instead, they might decide they want to implement their visibility by using coroutines and animate it that way. So this doesn't use DoTween. And I can prove that by, if I click on the UI and I click on this thing here, you'll notice it's got no dependencies. So list of assembly references, none. Why is that? Well, because I have this thing here called, where is it? My scripts. Oh, here we go. It's this one. So under here, I have this folder called third party. And third party is the boundary line where my code interacts with third party code. In this case, I have a set of visibility options which relies on DoTween. So if I have a look at that, this is a version of the UI which implements the DoTween modules. So it's exactly the same kind of stuff. For example, this one, and I'll just compare them side by side so you can see the difference. UI, visibility, canvas group. So this is a default visibility, and it's literally saying, take the canvas group, set the alpha on or off. All it does, very straightforward, no dependencies. Using statements, it just uses Unity. That's all it uses. But the fading version uses DoTween. And in this case, it's a tweened visibility, and it does a fade over a certain duration. That's basically it. The only difference is it references DoTween, but like I said, the rest of the code doesn't rely on this. Only this portion does, because this is a version of visibility stuff which uses DoTween. And if you're wondering what the tween visibility does, this is just a bit of caching for that tween. So a lot of people use DoTween by just firing off tweens, and it's fine. DoTween is actually very smart and does a lot of memory management for you. But if you want to be extra performant, you can take the tween, create it, set it to auto kill false, pause it, and then reuse the same tween multiple times. And then when you dispose of it, just kill the tween. And that way you're managing the garbage generated by your tweens yourself. So that's all this does. It basically says, if this is a tween whereby it has to manage its own life cycle, if I just extend from this tween visibility, then I can do whatever I want and I don't have to think about that code again, right? And there's different ones. So that was the one that does the fading. I have another one in here that does the slide. So here's the sliding version. How does that work? Well, it takes in a rect transform, some easing properties, and which direction you want. It turns that direction based on the width of the rectangle. So if it's whatever the size of the object that you're tweening is, make a second position off screen in that direction by that amount with a certain offset, and set that tween to go from A to B. So all this does is pick a second point that's X width away from the previous one. But again, it doesn't matter. It's just a implementation of tween visibility. I can have a million implementations. This is just the one I happen to pick here. In this case, do anchor position from and to with a set duration. And right, so then, oh yeah, the same thing with these text source. You'll notice that for all these canvases, my personal preference is TextMesh Pro, because TextMesh Pro is awesome. It's just a better text solution. Like this, you just don't want to use the native one. You want to use the TextMesh Pro version. But again, I don't want my code depending on TextMesh Pro, because I may be using it, but I may change my mind. It came along and replaced all the existing text stuff. What if a third library comes along and replaces all of that text stuff, right? So you don't want to be stuck in the same position where you have to rewrite all of your scripts because TextMesh Pro is being removed from your project, or another third-party library comes in. So you'll notice all of the display stuff that's in UI, none of it references TextMesh Pro. And again, I can prove this. If I click on the UI portion, what are the references in the assembly definitions? None, because the concept of UI displays and UI visibility in my code is not UI visibility depending on TextMesh Pro. So how do I do that? Well, same thing, UI TextMesh Pro. This version is where I keep all of the TextMesh Pro versions of my stuff. And in this case, you can see here, it references TextMesh Pro and it references my UI code. And in this case, is one thing. It's literally just a single script which knows how to turn a text display into a TextMesh Pro settable text display. And what does it do? Really straightforward. It takes in a TextMesh Pro text and does various things to it. Applies text to it, adds it, sets the text. And by the way, if you're setting text directly to TextMesh Pro, use the set text function, not the plus equals, because set text will help with, it'll use the string builder in the background and save with garbage collection. I'm only doing this in cases where you're appending, and you can't really get around that in a nice way unless you're actually building your own string builder, which I do in a different example, but I don't want to muddy the waters too much. I think I'm already going down a lot of rabbit holes. Right, are there any questions so far? Let's see. Let me see here. Is the code available? I can probably display the code. I can probably put it up on GitHub or something if people are interested. Hmm. Right. So I think we're coming up to probably where it's probably a good place to end some of this. I don't really know where else to go. I guess it's just I just want to highlight the fact that I've specifically made a point of designing a lot of this in and around the idea that there are boundaries in my code that will change. And some of them are obvious, some of them are not. In my case, what I display, how I display it, and which sources I'm using are the things that will change. So as I've kind of naturally grown this software, I've drawn boundary lines between the logging stuff, the console stuff, then obviously the common stuff or whatever, and then the UI kind of fancy animation, whatever. Because each of these things have their own reasons to change and their own decisions I might want to kind of move around with each one of those. Now, there's a lot of reasons for how I got to here, and I don't think I'll be able to explain those in a short amount of time. But I just want to really highlight to people, I didn't start with this solution. This isn't the code that I wrote down on a piece of paper. A lot of people get the idea that architecture is about writing a 50-page document that highlights all the parts, and this may seem very complicated and possibly even over-engineered, but the fact is, this grew like this. I started with the requirements I had, and I kept changing it. And so a lot of these things are extended features. And I could probably delete or pare away the ones I don't want anymore and end up with a much smaller set of classes if your worry is that it feels like a lot of classes seems bad for some reason. But it doesn't matter, right? Because like the point is that I end up with some result that's clean, easy to manage, and easy to extend. I can go in and change different consoles. I can go in and change different logging solutions. I can go in and create different formatters for stuff. For example, one I didn't show you here is currently the handlers I'm using are handling UI versions, but I've built a handler which writes the text files. And I've built a handler which can send it off to something like Rollbar or Log4net, third-party solutions. And because it's a composite log handler, I can just provide multiple different sources. And one of them happens to be an existing console, one of them happens to be third-party or whatever. I don't use them because, fun fact, Unity actually logs all of these for you. So there is a log file both on your computer and also in builds you can just open and read. So there's no point in manually logging my own logs again. This is purely for readability purposes. But I could start sending log messages to third-party sources and I wouldn't have to rewrite or change any of my code. So I'm going to just have a quick look and see if there's any comments before I call it quits.
Hey, sorry, where we at?
Oh, I was literally just signing off, so that's great. So it's good you're back.
Thank you, Jason, for taking over the stream there. I really do appreciate it, and thank you all for your patience there. I'm still doing some work stuff. I'm on a call right now.
That's fine. I can kind of hold the fort.
You want to? So you're about to sign off though, or we think we're
well?
Good?
No, I'll stay a bit longer. I'm just reading through some questions. While I was doing that, I obviously couldn't read the questions, so I'm kind of now just catching up on whatever what questions were there.
Gotcha. All right, cool.
So one of the questions here was those assembly definitions are very narrow, which you expect to be very large numbers. So I think that's a mistake to reason about assembly definitions as being in any way related to the number of files. The point of an assembly definition is to draw a boundary line between things that are related to each other. If you don't need it, how do I describe this? Like, it doesn't matter if there is one file or 1,000 files inside of that boundary. What matters is is this a boundary where things are likely to change? You know, that's the part that matters. It matters whether or not that particular boundary line is one that will change or will not change. In this case, whether or not I'm using a particular animation library is one that will change. It might use DoTween, I might use iTween, I might use Surge, I might use any number of tweening libraries. And if I give my code to somebody else, they might want to use any of the ones I use or a different one. So it doesn't matter if there's one file, 100 files. It's the same with TextMesh Pro. I would say in 99.9% of cases, I'm going to use TextMesh Pro. I cannot really conceive of a reason why I would not. But I don't want a scenario where I give my code to somebody else and they can't use it, because littered throughout my entire code base is the phrase TextMesh Pro as an import statement. And I have to say, sorry, just upgrade your text. What if they want to import it in a legacy project? The way I have it now, just because I put a boundary line there with that assembly definition, they can provide their own implementation if they want. So again, it's got nothing to do with how many files are in it. It's to do with, is that a boundary in your application? And in my case, there are very clearly 3 boundaries. Recommendations for design principle books. I can, but realistically, I'm going to give you the same 3 or 4 everybody does. If specifically the kinds of architecture I'm talking about here would be from Bob Martin stuff predominantly. So you're talking about clean code and clean architecture. That'll cover why I drew the boundary lines I did. As for the patterns I used, like the null object pattern and like there's so many others in there. There's factory patterns, there's other stuff, builders. That's all from the Gang of Four design patterns books. So my personal preference would be, so they're the go-tos. I would say that I wouldn't worry too much about reading 10 books on design patterns. Probably won't help you as much as just sort of, as weird as it sounds, just thinking about your code architecture. A lot of people write code and try to copy patterns in from stuff they see, but you're far better off just trying to figure out what problem you have and try to solve that problem. Like, people who are a bit eagle-eyed might have noticed that the UI pattern I chose for the console, where I've split it up into the logic portion and the UI portion, looks sneakily a lot like sort of a model view controller solution. It does, it's similar, but I didn't do model view controller because in this instance, I don't have a model. And it can be a common problem where people will just know a pattern is good and they'll try to apply it. And they don't realize that a pattern is designed to solve a problem. And if you don't have that problem, applying the pattern is not only not going to solve it, it's going to complicate your code base. So I would say take a lot of the design pattern books with a pinch of salt and don't just start applying design patterns to your project. Instead, try to figure out what the problem is that the design pattern is solving. And that's why I recommend the Head First design pattern book instead of just sort of learning about patterns in general, because they do a good job of teaching you, this is a problem. How do we solve this problem? And they sort of, if you go through the narrative of the book, they'll sort of have people kind of work their way into problems and then use a design pattern to solve their way out of it. And that's kind of the biggest life lesson I can give with a lot of this architecture is architecture grows. Architecture is not something you lock in place. It's something that happens as you start to design and change your code. So you'll notice how it may have ended up very complicated, but I promise you the first line of code I wrote was debug.log. The next line I wrote after that is I did a bit of a Google search, found out about that Unity logger, and I said equals new my handler, and I checked what it does, and I incrementally stepped through it. The difference would be a lot of people would incrementally step through it and then delete and throw away the old code. I don't delete and throw away the old code. If I write it and it works and I have like a basic log working, I will find out that this is the bit I want to change. I will refactor it, move it out, put a new implementation in place, keep going. And now I want to change it again. So I take this piece, refactor it out, put a new one in place. And you'll notice the architecture happens, right? It's not something you have to worry about as this complicated, how did he reason about where to put all these lines? I didn't. That happened because I needed them to. I wanted to print a log, and first I tested it on text box. And then I thought, well, now I want to move it to print it onto a TextMesh Pro. How do I do that? Well, I can't do it right now because the text is already in there. So what if I take that one out and I put a TextMesh Pro in? And I did that. And then after a while, I kept going and I would just move these pieces out bit by bit. And the architecture you saw is the end result, if that makes any sense. Um, I have no idea. I have no idea how to know when a live stream is ending. I think we're running out of questions. Yeah, and as for people talking about third-party logging solutions, yeah, I've done that before. And again, that's kind of part of the reason of doing this, right? I want to see these logs because they're the runtime logs I want to look at in Unity. Um, Personally, I use Rollbar in the past and Log4Net. And that's simply just adding another handler to extend the existing one. Like you can basically defer those logs if you need to. There's a ton of third-party solutions. It really comes down to what your goal is. I built applications which are deployed to multiple locations, and if an exception happens, you need to fix it pretty much immediately. So in those cases, you build a hub. You'd either choose to use something like Log4Net and view all the logs in some sort of localized way. Again, Rollbar is a service which actually shows you the logs on their website and lets you send them there. Or in other cases, we've sent the logs to our own web API and then aggregated them there. And then you can use something like Grafana and so many different solutions. You can actually build like workflow HUDs, and it'll show you like how many devices are failing or how many people have logged in at any one time. There's a million ways to extend logging. And I guess the point isn't what ones there are, but the fact that I could do that now and I don't have to change any of my code, right? And I guess the other thing too is because Unity put that layer in for me, it may seem like a silly thing, but I've interjected into the middle of Unity's own logging solution, which means I could drop this code into another project and they don't have to switch from debug.log to JSON system.log or whatever, because I'm using Unity's own handling solution for that problem. So it may sound like a small benefit, but just think about the fact that most libraries you use require you to change the code you write to support whatever their platform is. If you're using like a third-party sort of visual logger, I've noticed a lot of them require you to actually like write to their log, and this kind of thing lets you not worry about that. Yeah, in short, MVC is not a game design pattern. It's specifically designed for event-driven systems and normally ones that have a separate repository layer where the persistence is different from the controllers. And there's regular comments on the Discord where I'll actively say, don't use MVC. And I put an asterisk there and I say, I tell people not to use MVC because most people misapply it and they'll just start putting a load of random stuff into their project. But you'll notice in my case that I'm using something MVC's like, you know what I mean? And that's because it does literally solve the problem that I have. How many years of coding is needed to get to that kind of knowledge? Well, I've been programming for 12 years, 13 years. And I can honestly say for about 6 years, I would spend minimum 8 hours a day programming. So yeah, quite a long time, I guess, is the answer to that question. So don't worry too much. You don't have to know all of the answers straight away. You have plenty of time to figure it out. Yes, I know my name is in the calendar. I used to circle it when I was a kid. So yeah, I guess do people want that project? Will I bother putting it up on GitHub? Maybe I'll make a package out of it. One of the package assembly you can add to your project from the package manager. I don't know. I haven't really put much thought into it. It wasn't really for other people. It was just when Charles suggested we show each other's code to sort of prove that we actually do kind of know what we're talking about. It just happened to be the thing I was literally working on at the time. Yeah, okay. I'll find a way to put it up, and I'll drop it into Discord. So if you're not a member of Charles's Discord, I would recommend you join. I think there's a link somewhere in the bottom of this video, and then you can see it when I post it.
Hey.
Welcome back.
Yeah, I'm not back, unfortunately. I actually put my call on hold. It sounded to me like as though you were wrapping up. Is that true?
Yeah. I was just saying that I'll make the project a something that I can post up on GitHub or something. I think it's a good enough place to end as any.
Cool. Well, yeah, thanks again, man. I appreciate it. I kind of heard snippets of you like answering questions, so it seems like there was some good stuff. I'm actually gonna watch my own stream now because I'm curious to see what you covered. But yeah, let's go ahead and end it here. Did I hear you're going to put the code up? You're going to make it available?
Yeah. I think I'm debating whether it's going to be a GitHub project or whether I'll just do what you suggested and do the package manager stuff. But
yeah, true that. All right, man. Well, thanks, Jason, for pretty much taking the stream under your wing and making it so awesome. Thank you, everyone, for watching. Really appreciate it. A lot of viewer activity, so there was great engagement. So I hope it was as valuable to you all as I'm sure it will be to me when I watch it back.
And don't forget, if you found anything valuable, we would greatly appreciate upvotes. You'd be surprised how big of a deal that actually adds to the algorithm. Everyone hates saying it, but the truth is, it genuinely helps.
Yeah, upvotes and actually comments too are really helpful. Not only obviously to the algorithm, but like when you post comments, sometimes if I'm like my tank's running dry on ideas for a video, I'll just scan the comments or I'll remember a comment that I saw. In fact, I think the assembly video, a couple people had left comments about it, and I was like, you know what? People keep asking about assemblies, like that's a great thing to cover. I'll go ahead and cover that. So it's just helpful all around, just to kind of make sure that we're providing the content that you want to see. So do that.
Yeah, if any of this stuff, because I'll be honest, I do feel like I sort of glossed over a lot of stuff. That kind of happens again. Like this wasn't meant as a lecture or a lesson. This was just sort of a peek under the hood to make sure people kind of realize, just so it doesn't look like we're lying, that we do know vaguely what we're talking about. And so because of that, it wasn't structured in a way that was meant to make a lot of educational sense. So if there are things in there that were a bit kind of, if I glossed over them or I didn't cover them in a way that made sense, feel free to put a comment, or if you watch over it and find timestamps for parts that I didn't really cover. If you put comments down, I can kind of go through those, compile them, and I can possibly reference them or cover them next time.
Yep, that's a good idea. Yeah, I think our goal is to kind of craft some of these streams to not just be hangout sessions, but to be targeted, so almost like live tutorials. So anything that you'd like to see like that, that would help us craft that. So. Okie dokie, I got to get back to work. I got someone on hold here. So thank you all for joining again. Have a good weekend, and catch you in the next one.
Good luck.
Later.